Hey everyone, today we're going to be looking at question set 8, partner A. To solve this problem, you will need to know your prior knowledge from algebra, pre-calculus, geometry, and calculus AB. You will also need to know integration, graphing functions in the calculator, and how to use a graphing calculator, and the formulas involved in finding volume of cross-sectional areas. Additional information to know are the equations for area and how to take definite integrals by hand to calculate the volume of the rectangular cross-section. Common errors occur when taking the definite integral. When taking the integral, people can make mistakes like taking the derivative instead of the integral, using u substitution where it's not needed, and using the product rule while integrating. Another way that people can make errors is when they plug the values of the definite integral in using the fundamental theorem of calculus. Mistakes people can make while using the fundamental theorem are plugging the values of the definite integral backwards into the equation, plugging the wrong values into the fundamental theorem due to poorly labeled work. Mistakes can also occur when people misread the problem. For example, people can make mistakes like not paying attention to if it's a perpendicular to the x-axis or the y-axis, misreading the range of the cross-section, ignoring other important information given in the problem. In part 1, we're asked to sketch region T and mark any points of intersection. We know that region T is bound by the x-axis, the graph of f of x, and the graph of g of x. We also know that f of x equals square root x and g of x equals 6 minus x. To sketch region T, we are going to need to plug in the given equations into the calculator. So I'm going to put f of x into y1 and g of x into y2. So y1 equals square root x and y2 equals 6 minus x. Then I will change the window settings so I can clearly see what the equation is when I graph it. Okay, so here is the graph now. We will now shade the region that we need to find, which is region T. Make sure to label that region with the T. Also, label your lines as g of x and f of x to help you later on in the problem.
We also need to label a sample base because later on we're going to be using cross sections. We can tell that the first point is 0, 0 by looking at the table. We can also tell that the second point is 6, 0 by looking at the table. But to find the third point, we're going to need to go to second, calc, and then intersect, and then hit enter 2 times to figure out the point of intersection of the two lines, f of x and g of x. The point of intersection of the two lines ends up being 4, 2. For part 2, we're asked to find the volume of a solid where the cross-section, where the y values between 0 and 2 is taken perpendicular to the y-axis, and the base of the rectangle lies in the area T, and the height is going to be 2y. To solve part 2, we first started off by changing y equals the square root of x to x equals y squared, and y equals 6 minus x to x equals 6 minus y to put the problems in terms of y instead of x. Then we know that the length of the base is going to be 6 minus y squared from the two equations that we were given. Now we're going to plug everything into the cross-sectional volume integral, which is going to be the volume equals the integral from 0 to 2 of 2y times 6 minus y squared dy. Now the 2y comes from the problem where it says that the height is 2y. So you're going to want to multiply that by the base, which is 6 minus y squared. And then the definite integral comes from the problem where it says it's between 0 and 2. The next step, I just pulled out the negative 2 to the outside of the integral to make stuff a little simpler. And then the step after that, I multiplied the y inside of the parentheses. So then you get negative 2 from 0 to 2 of y to the third plus y squared minus 6y dy. Now you're going to take the integral of the problem and you're going to get negative 2y to the fourth over 4 minus 2y to the third over 3 plus 12y squared over 2 from 0 to 2. With some simplification of that, you're going to get that going to volume equals negative y to the fourth over 2 minus 2y to the third over 3 plus 6y squared, and that is still going to be from 0 to 2. Now you're going to plug in the fundamental theorem of calculus to solve for the actual value. When you plug in the fundamental theorem with the a and b, you're going to get negative 2 to the fourth over 2 minus 2 times 2 to the third over 3 plus 6 times 2 squared, and that's all going to be minus 0 to the fourth over 2 minus 2 times 0 to the third over 3 plus 6 times 0 squared. Now, once you simplify all of that, that is going to come down to 48 over 3 minus 16 over 3. And that will simplify down to your final answer of 32 over 3, which is the volume of that cross-sectional area.